Welcome to Techie Wise. In this video, we will have the discussion on AES key expansion process. So, AES takes three possible key options: 128-bit, 192-bit, and 256 bits. Depending upon the key size, the number of rounds in AES algorithm also varies. For 128-bit key, the rounds involved are 10. For 192, it is 12. And for 256, it is 14. So how many keys are required? How many bits are required for a 128-bit version? So here in the 10 rounds are there. Each round requires 4 words of 32 bits. So in addition to that, we will have one more add round key. So plus 4 words are required. 4 words are required. So 44 words are totally required. Similarly, it goes well with 192 bits also. 12 into 4 word plus 1 4 word for AND round key. So what is the user input? A 128-bit key. So with that 128-bit, we are in a position to generate 44 32-bit words. Only 4 words are available with us. With that, we have to expand to 44. How it is done? So this is how it is done. So here, for 128-bit are placed as 16 bytes. So this is the 16-byte representation. First 4 bytes forms the first 32-bit word. Next 4 bytes, next word. Next 4 bytes, next word. And the next 4 byte is W3. So first 4 bytes are directly taken from the 128-bit key. So what about the remaining words? So each 4 word can generate the next subsequent 4 words. So with these 4 words, we can generate the next 4 words: W4, W5, W6 and W7. With these 4 words, we can generate the next set of 4 words. Like that it goes on. How this is getting generated? So here you can see W4 is dependent upon previous 2 words, that is W0 and W3. Similarly, W5 is dependent on W1 and W4. Like that it goes on. So in generalized version, we can say that Wi is dependent on, that is W4 is dependent on W3, that is Wi minus 1, and the word which is 4 words apart. So that is W0. That is Wi minus 4. So this is the generalized version. So how, with these 2 words, how this word is getting generated? So from 4 words, we can generate 4 more words, right? So out of these 4 words, 3 out of 4 words involves a simple XOR operation. So that is W5, W6 and W7 are generated by means of a simple XOR operation with Wi minus 1 and Wi minus 4. So what about that 1 by 4? That is 1 out of 4 word. That is W4. W4, 1 out of 4. Here in this case, the words whose array index is in multiple of 4 will come across a complex G function. So here you can see W5 is just an XOR between W4 and W1. W6 is just an XOR between W5 and W2. Like that it goes on. But what about W4? It is an XOR between W0 and G of W3. So W3 come across a G function and then the output is XORed with W0. Alright, 1 out of 4 word, that is whose array position is in multiple of 4, will depend upon this G function. That is W8, W12, all those things comes across this G function. So what is that G function? So it is a 3-step process. So first step is circular left shift, circular byte left shift, that is rotate word. 1 byte left circular shift, and next comes the byte substitution, which is done with the help of the X box, and then comes the adding round constant, just an XOR operation. Each and every round will have a specific round constant. All those are predefined constants, just XORing it. That's it. right? So now we can, to have a better clarity, we can take an example and proceed with the task. So here this is a 128-bit key. So this 128-bit key, that is, we are going for this 128 10 round key version, 10 rounds version. So here you can see. So I need these keys given by the user will be directly used in the first add round key functionality. W0 to W3 will be used by this function. For rest of these 10 rounds, we have to generate the subsequent words. So how it is generated? Yeah, we can start with. So first 4 bytes forms W0. This is W1, this W2, and this is W3, right? So now we have to proceed computing the things. So W4, how I'm going to generate with these 4 words, we can generate 4 more words, W4, W5, W6 and W7. So what is W4? So W4 is W0 XORed with G of W3. That is Wi is equal to Wi minus 1 and Wi minus 4, right? So similarly here, this is W1 XORed with W4. W6 is W2 XORed with W5. And this is W3 XORed with W6. So this is XOR operation. So XOR we all know. So if bits are same, then it is 0. If bits are different, then it is 1. So that is 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, right? Okay. So all these things are very simple. Now we can have a look into this part which involves a complex G function. So now W3 comes across this G functionality. So what is the first step in G function? Rotate word is the first functionality. So rotate word. So what we have to rotate? Rotate word of 77 to 4B. All these are hexadecimal digits. 6, 5, 7, 9. So left circular shift by 1 byte. So what will be the output? 4B 6, 5, 7, 9, 7, 2. Just left a circular shift by 1 byte. Right? So the next comes what is the next step? So rotate word is done. Next step is S box. So what about S box? So this is the S box which involves 16 rows and 16 columns. How we will retrieve the values from the S box? Each byte is taken. First 4 bits are used to represent the row and then subsequent 4 bits are used to represent the column. So this is used to represent the row and this is used to represent the column in the S box. This S box will have a 1 byte entry. So now we can proceed with the conversion. So what is 4B? So this is 4, this row and this column. What is the resultant? B3. So the output of S box is B3. Next comes 6 and 5. So what is the resultant? 4D. Next comes 7 and 9. What is the resultant? B6. And next comes 7 and 2. 7, 2. So this is 7 and 2. What is the resultant? 4, 0. So this is with regard to the byte substitution. So next step is done. Byte substitution is done. Next comes the adding round constant. So here we are going to deal with the first round. So the next 4 words, that is W4, W5, W6 are given to this round, right? W4, W5, W6, W7 is given to add round key function of round 1. So each and every round will have a round constant, predefined round constant. For round 1, the value is, so what is the output of the previous round? That is byte substitution. It is B3, 4D, B6, 4, 0. Once done with the byte substitution, this is the output. That is what we are writing here. And the round constant for round 1, right? So what is the value? This is 0, 1, 0, 0, 0, 0, 0, 0. So now we are going to just add round constant. That is, it is an XOR between this and this round constant, that is 0, 1, 0, 0, 0, 0, 0, 0. Just we can represent it in binary. So what is the binary equivalent? 1, 0, 1, 1. 0, 0, 1, 1. That is 3 is 0, 0, 1, 1. And next comes 4D. So what is 4? 0, 1, 0, 0. And D is 1, 1, 0, 1. What about B? That is A is 10, B is 11, right? So binary equivalent of 11. So 1, 0, 1, 1. And 6 is 0, 1, 1, 0. What about 4? It is 0, 1, 0, 0, and this is 0, 0, 0, 0. And here this is all simple. So 0 and this is 0, 0, 1. All these, each digit is a hexadecimal digit. So 4 bits are required to represent an hexadecimal digit. All other is 0. Right? What is the, so this is the output of G function, right? This is the output of G function, W3 coming across the G function. So what is the resultant? So 1, 0, 1, 0, 1, 1. It is an XOR. So if bits are same, then it remains 0. If bits are different, then it is 1. So 0, 1, 0, 0, 1, 1, 0, 1. And here it is 1, 0, 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0. Right? So this is the output of G function. So what we have to do, we need to retrieve W3. We have to find, calculate W3, which is dependent on W0 and G of W3. So G of W3 already we computed. And what about W0? This is W0. Just perform the XOR operation between this one and the output of the G function of W3. So W0 is 896973, which is W0, right? So what is the binary representation? 8 is 1, 0, 0, 0. 4 is 0, 1, 0, 0. And this is 6, 0, 1, 1, 0. And then comes 9. So here, 9 is 1, 0, 0, 1. It remains the same, right? 0, 1, 1, 0, 1, 0, 0, 1. And next comes 7. So 0, 1, 1, 1. 3 is 0, 0, 1, 1. So just perform the XOR operation. So 0, 0, 1, 1, 0, 1, 1, 1, 0. Right? And this is 0, 0, 1, 0, 0, 1, 0, 0. And what about this one? 1, 1, 0, 1, 1, 1, 1, 1. And this is 0, 0, 1, 1, 0, 0, 1, 1. So what is the hexadecimal equivalent? So this is 3, 6. And what about this one? 2, 0, 0, 1, 0 is 2, 0, 1, 0, 0 is 4. And this is D, and this is F, and this is 3 and 3. So this is W4. So like that, we will proceed complete. W5, W6, W7 is going to be an XOR operation. Once this is done, then we can compute the next subsequent 4 words. That's it with this is how the key generation process works in the AES algorithm. That's it with this video. The next video, we can have the discussion on the encryption part. Thank you.